MATLAB is a powerful tool for many researchers. This video series covers the basics of working with our Neural Processing MATLAB Kit, or NPMK for short. If you don't have the NPMK yet, you can download the NPMK from the download section of our website, or on GitHub under NPMK. The NPMK is primarily used for loading BlackRock data into MATLAB, but it has many additional functions for manipulating BlackRock data and data files. This tutorial will cover the basic use of the two most common functions in the NPMK, OpenNEV and OpenNSX. To get started, make sure that the NPMK is set on your path, or that you are within the NPMK folder, like I am here. Both OpenNEV and OpenNSX can be found in the main folder of the NPMK. All functions within the NPMK have extensive help documentation that describes each of the available parameters. That said, all parameters of both OpenNEV and OpenNSX are optional, so we will try to start by simply loading a data file without any special parameters. As the name suggests, OpenNEV handles our NEV files, or neural event files, and OpenNSX handles our continuous data files, such as NS2s or NS5s. Since the NSX file format is a bit simpler, let's start with that one. To open a NSX file, simply type OpenNSX. This will open a file dialog for you to open your NSX file. I'm going to choose from here some of the sample data that is available on our website. After selecting the file, NPMK will quickly create a structure that contains a few pieces of information. Meta tags contains meta information about the file, such as a recording date, number of data points, and sampling rate. Data, of course, contains the data from the file. Each row represents a channel or electrode, and each column is a data point. Raw data, generally, doesn't need to be used. It contains information that the NPMK makes use of. Finally, electrodes info contains information about the electrodes. Like the data structure, there is one row in electrodes info for each electrode that was recorded from. This structure contains information such as the label, channel number, and filters. With the organization of the data structure, it is really easy to plot a signal. I'm going to plot the first couple seconds of channel 1 of this data file. Since I know that I'm sampling at 30K, I can simply plot from 1 to 60K to capture the first 2 seconds. OpenNSX has a number of parameters that can be passed, such as specifying file name so that it can be used in a script, downsampling the data, or opening only specific ranges of time or channels. All of these features are covered in the help documentation and can be accessed by typing help OpenNSX, or simply by opening the function. With the basics of OpenNSX covered, let's take a look at the slightly more involved OpenNEV. Just like OpenNSX, we can open an NEV file by simply typing OpenNEV. This also opens a file dialog in which we can choose our NEV file. I will choose the NEV file that is paired with the NS5 file that I opened earlier. The NEV structure contains similar looking fields to the NSX structure. Meta tags contains a number of the same fields as we saw in the NSX structure. Electrodes info also contains the same information. Data is actually a structure that contains a number of substructures that contain different types of data. I/O labels generally does not need to be dealt with. It contains some titles that are used in other places in the NEV structure. Let's look at the data structure, since that contains all of our new information. As I mentioned earlier, NEV files stand for neural event files, and they contain everything that is not continuous data. This means that they contain spikes, digital inputs, tracking events, comments, and other event-based data that is used a little bit less often. Serial digital I/O contains all of our serial inputs and digital input data. Spikes contain spike data, and comments contain any comments that we committed to the file during recording. To learn more about comments, check out our series on the basics of Central. The video sync and tracking structures contain information from our video tracking system, Neuromotive. Patient trigger and reconfig are not often used, but contain information from external events that can occur in certain system configurations. To get an idea of how each of these fields are organized, let's look at spike data. For any given spike, there are a few pieces of information that we can associate: the timestamp at which the spike occurred, the electrode on which it was recorded, the sorted unit that it is assigned, and the actual waveform itself. The way that this structure is organized can be seen in the length of each matrix. each of these fields has the same number of columns, because each column represents all of the information about a single spike. Thus, the first entry in the timestamp field is associated with the first entry in the electrode field, unit field, and the first column of the waveform field. For example, I can see that our first spike happened at timestamp 4302 on our 30 kilosample clock. It happened on electrode 3, and I can see the waveform values by looking here. To plot this waveform, I can simply type plot nev.data.spikes.waveform and look just at the first column. And now we can see a nice spike waveform. The remaining structures are organized in this exact same way. Each index is associated for all of the different pieces of information about a single given event. Like OpenNSX, OpenNEV can accept a number of parameters to allow more flexibility in its use. That finishes the basics of using OpenNEV and OpenNSX, the primary data loading functions for BlackRock data, into MATLAB. Thank you for joining us today for this tutorial, and be sure to check out our other videos for quick tutorials on many of our products. For additional information on any of our products, manuals can be found at www.blackrockmicro.com.